So fresh off the previous video, I've got my point class again, but in the meantime, I have added a new function, .print. Because I figure I print so many points out, maybe it's good to have that be a standard feature of the class. Great. But I think about it for a minute and I realize, wait a minute, if I want the point to be an abstraction, if I want it just to be a point, I don't want to have to give it special treatment. I want to treat it like any other piece of data. So I can, if I want to print it out, I could do something like this. I could do print, I'd say point p, and then I could do p.print. And that would work. That would do the trick. But I think about this and realize a programmer using my object wouldn't know to call .print. He'd have to go figure that out, that's a special thing you do with this object. Most of the time when you want to print something out, like a string or an int, is you push it into the standard output stream. You use this. Okay, so why don't we just try that? Okay, so let's see if I can do this. Instead of writing p.print, I'll just take p and shove it into the output stream. Because I can do that with other types, why not this one? And so we'll try it. And, we'll feel a bit sorry for the poor compiler this week. And the compiler, obviously, has just been a rough week. Clearly, it does not like this. And it really doesn't like this. It was having a problem before, but we've really pushed it over the edge here. And we start at the top and say, okay, no match for this. And I foreshadowed this. It turns out that the stream insertion is in fact just a clever use of operator overloading. This is actually a binary arithmetic operator that has been repurposed in C++ for output when you work with these output streams. Okay, so what this is saying is there's no match for this. I can't push a point into it because nobody has explained to me how to use this operator with a right-hand operand of type point. And we sort of know by now how to fix that. We've got to add our own. And we should, because then I could just push the point directly into the stream. Before we do, I want to scroll through some of this garbage that's printed out and see if we can decipher anything. I want to illustrate why it's generating such a long error message. You'll notice it keeps generating sort of repeated things about a candidate and no known conversion. And if we scrub through a bit, we might pick up on what it's doing. So here we have no known conversion from point to long int. Well, that's weird. Let's see if we can find anything else that we can recognize. Point long unsigned int. Point bool. Point to short int. And if we go a bit further, there's short unsigned int, there's unsigned int, long int, double, float, long double, null pointer, this thing, which we might recognize as, that's not what I'm talking about. There should be one in here for string, although it's going to use the really ugly long name of a string. What it's actually doing here is it's saying it's trying to go through every possible thing it does know how to push into the stream and explain to you why this didn't work. So what it's saying is basically, I know how to push an int into the stream, but I can't convert p to an int. I know how to push an unsigned int into the stream, but I have no way of converting the point to an unsigned int. The compiler is desperately trying to make you believe that it's not the compiler's fault that this operation failed. It's printing out everything it tried and why everything it tried failed. The solution, of course, is to define our own operator. Now, unlike plus or less than, this operator is purely synthetic. It's a made-up operator. I mean, it's an operator that already exists, but the meaning of pushing something into a stream, that's completely made up by the standard library as a part of this output convention that we've had to put up with in C++. So there's no sense in trying to worry about exactly what this is supposed to mean, besides that it means that I'm pushing something into the output stream. So I want to write the operator. Let's just start with this. So it's going to be called operator angle bracket. I'm going to do it with type void as the return type because I've never seen this stuck in a function call or anything, so I suppose I don't need a return type until maybe later in the video. And then I have to think about what the first argument is. Okay, so on line 46, I'm using the operator, there it is, and on the left I have whatever cout is. So to be clear, if you're watching this, there's not going to be an exam question about writing this particular operator, the stream insertion operator, because I know that that's sort of it's important to know we can do it, but it's a bit tedious. And if I want you to write operators, I can give you something more accessible, like a plus or a negation or something. And frankly, if it's an open book exam, you could always bring this information in. I guess you couldn't bring the video, but it turns out the type of cout, the variable cout, is actually a global variable, and its type is stdostream. Now, we haven't done any videos about file I/O in C++, but by now in the course, you've seen them in labs. And you're probably familiar with the fact that you can use file streams the same way you use cout, and they're often of type something like ostream or ofstream. The type of cout is stdostream. Well, it's got a complicated name that we're not going to worry about. We'll just say it's stdostream. And so that means the right-hand operand should be one of these. And it turns out here that you have to take it by reference because it is not permitted to copy an object of type OStream. So cout is an object of type std_ostream. Ostream is a class that prevents you from copying its instances because, of course, we know a class has complete control over every instance of the objects of its type. And one of the things you can control is whether copies are allowed to be made. So far, we've seen generally you can make copies of class objects, but it turns out you can prevent that. And we're actually going to see how to prevent that later. But for now, you take as your first argument the stream, so an object of type OStream, and as your second argument, you take the thing that you're trying to print. So I'll call it point pt. Okay, now I have to define what it means to print it. Well, I'm going to do something similar to what I do up here. I push into the stream pt, I push in a bracket, and then I push in pt.getX. Then I push in a comma, and I'm going to do a space. And then I push in pt.getY. And another bracket, and that's it. Okay, and you'll notice in the operator that I'm defining, I use the same operator. But remember, this is the operator, the one I'm defining is the one that takes a stream and a point. The one that I'm using takes a stream and then a string, or a stream and then a double or something. So I'm not actually using the same operator in this definition. I'm just using one that has the same syntax. Okay, so we'll try that and see if that works. And sure enough, it does. And so we'll try running it and see what it does. And it prints out point p equals 6, 17. Sure enough. Task number 2. I want to run this. I want to print out both p and q. And I mean, I thought we wrote the operator, so let's see what happens if I run this. And the compiler gets upset. But this time, it's not as upset as it was before. It doesn't seem like it has trouble finding the operator, or maybe it's not, it's running into trouble in a bit of a different way than earlier. I suppose that you could argue it's still saying no known conversion. But if we stare at this, we notice something odd. It's saying, okay, I can't find the definition of the operator that takes on the left void and on the right a point. Operand types are void and point. Void? Where's void coming into this? So the issue is, this is one operator, and it takes 2 operands. All semester, this has just taken 2 operands. When I do the clever trick where I jam a bunch of output statements together, really what I'm doing is just applying the operator over and over again to itself. The same way that in C++, if I write something like 6 plus 10 plus 17, what I'm really doing is computing 6 plus 10 and then adding 17. We know from 111 this idea of precedence and associativity, where the implicit brackets go. The same is actually true of the stream insertion operator. When I run this operation here, I'm really just doing 2 applications of a binary operator, and the brackets would look like this. So what the compiler is complaining about is, well, what actually comes out of this expression? Well, according to the return value of my operator, void. And so I think it's quite rightfully saying, I'm sorry, what comes out of here is something of type void, which is already a bit of a oxymoron, because how can you have a thing of type void? I'm not able to push a point into a value of type void. So if we reverse engineer this, okay, so I guess I need to change the return type of my operator. What return type would result in this working? Well, I want to push Q into what? I want to push Q into cout. So what I sort of want is for this expression to turn into, I guess, like I evaluate it and it ends up being cout. I end up pushing Q into cout. So maybe what I want to do is, when I'm done doing this operation, the operator should just return the stream so that you can push more stuff into it. And so you end up with this very odd looking operator where it takes a stream and then returns the stream. And notice how I return it by reference because I'm not allowed to make copies. And we'll try that. And I'll make sure I still have this uncommented. Well, I'm going to get rid of the brackets, but we saw that it compiles with the brackets, and we'll see that it also compiles without them. There we go. We run it, and it works. So now we're able, this is the orthodox way of writing such an operator. If you're writing your own output operators for your own types, which you often will do, you'd write it looking like this. It takes a stream on the left, and then it returns the same stream, which allows the operator to be chained together like this in the way that we're familiar with. But you saw in task 1, you don't actually have to do that. It's just the operator that you need. You just need some way of taking the operands and doing the actual, doing the operation. You don't need to return anything, although if you don't get the convenience of the output statements that we've been using. One last thing at the end, what happens if I don't take it by reference? So I said you have to, so I suppose I better put my money where my mouth is. just because we're torturing the compiler today anyway. Let's see if we can figure out, okay, so first it says you can't return a reference to a local variable. Now to shut it up about that, I guess I shouldn't return a reference if it was a copy, so we'll try that. Okay, so what's the error that it actually produces here? And if we stare at it, so we'll scroll to find the error, it says, it uses this word, that's interesting, the word protected. That's neat. And if we stare at it very carefully, so there's std : ooh, the name of a class, : the name of something, and then a bracket. And it might not be too obvious, but it turns out that if this is the name of a type and then a bracket, it's actually complaining about a constructor. It's saying this constructor isn't available to you. It then says this term use of deleted function. We might see this error later in the course. What's really happening is a special constructor gets used when you copy an object. The object needs some control over how it's copied. There's a special constructor you can use to copy objects, and if you make that constructor private, or you make it non-public, because it doesn't say private, it says protected. If you make that constructor non-public, then nobody from the outside can use it, and that's a way of forbidding the outside world from making copies of your objects. And that's why we have to pass std_ostream objects by reference. And it makes sense that that's the case, because cout is referring to one output destination, the screen. So it wouldn't make sense if we can make copies of that. What if two different copies of the screen or the output destination existed? It wouldn't make any sense. So that's one reason that the object restricts whether copies can be made. Now we'll see how to do that restriction ourselves later. But for now, when you write your own operators for generating output, you'll make sure to take the ostream object by reference and then return it also by reference.